Hi everyone, let's see how you can win a roulette using probability. So you must have heard these lines: casino always wins, house always wins. So you must have wondered how these players like predict that they're gonna win, they're gonna lose, and so let's see how we can predict that. So for now, we'll be taking example of a American roulette, right? So it contains 38 numbers, and the players bet on these numbers and win prizes, right? So if suppose you put your coin in one, then you get 35 cross one, means like if your input is 2 rupees, 2 rupees, like you put 2 rupees coin, so you will get 70 rupees, right? How you will get? Suppose you put your block here, then this roulette is spin. If somehow you get one is where, yeah, one is where, yeah. If somehow you get one, right? This one, you will get your 70 rupees. But if suppose you missed one, then you lose this 2 rupees, right? So let's see how we can like predict who's gonna win using probability. More specifically, we're using expectations. If our expectation value is positive, so there's a more chances that you're gonna win. If somehow is expectation negative, if somehow is expectation negative, don't even play the game. Don't even play the game. But if somehow expectation is greater than zero, then go for it. There's a high chance that you can win the price, like amount that you put here, right? So, for example, I have made my own roulette, right? With numbers 1, 10, 3, 7, 16, 15, 5, 1, 19, 20 to 8, right? And with their values, if you will get 1, you will be win with plus 3. If somehow you get 10, you will get lose minus 1, right? This is my own game, right? So let's see how we can predict. So before going on, let's see the probability of winning and losing. If somehow I write win, right, it means you need to mention the probability that you will win always. And suppose win, right? So 1, 2, 3, 4, 5, 6, 7, right? So 7 upon 1, 2, 3, 4, 5, 6. So there's 12 numbers, and probability of lose will be 5 upon 12. So although you it seems that probability is more, like winning probability is more, so you should win, but uh, हमेशा ऐसा नहीं होता. Let's see how we can predict, right? So we will see first, we'll see the probability of winning and losing. Not probability, more specific, we'll be dealing with random variables, discrete random variables, find out the expectation value, right? So let's suppose my random variable, discrete random variable is x, right? So what can be x? X can be minus 1, right? Sorry, not minus 1. X can be, oh, sorry, 1, 2, and 3. Now I will draw probability 1, 2, 3. 1 is losing 1, 2 is winning 2, and 3 is winning 3, right? This is my x, this is my probability x equal to xi. Now we will see number of time you are losing and getting minus 1, right? So 1, 2, 3, 4, 5. So it's 5 upon 12. Now let's see number of time we're getting 2 plus 2 win. So 2 time you're getting 12, and let's see plus 3, 1 plus 3, 2 plus 3, 3 plus 3, 4 plus 3, right? And wait for a minute. 1 plus 3, 2 plus 3, 3, 4. Right, we're getting 4. But they are not giving me some as 1, right? 7, 4, 11. I guess we're missing some stuff. Let's see, lose 1, 2, 3, 4, 5, right? Let's see, 2 plus 2 plus 2. So 2 times, acha, we're getting 3 time plus 2. So it will be 3 upon 12, 3 upon 12, right? So now let's calculate our expectation. So expectation is always taken for n trial. This is my first trial, right? This one is my first trial. Now we'll do our n trials, and then we calculate our expectation, right? So let's calculate the value. So for n, it will be n. One is losing, right? One is losing plus 2 plus 3, right? So माइनस वन की प्रोबेबिलिटी 5/12 और वैल्यू क्या है -1. नाउ लेट्स सी फॉर 2. So n cross 3 upon 12 cross 2. Since we are winning, so I am writing plus 2. Since I am losing -1, so I am writing -1. And then n 4 upon 12 into 3. So let's calculate the sum. The sum is -5n by 12, 6n by 12, and 12n by 12. So right, it will give me 1n. So it will give me 13n upon 12. That's my expected value. Since this is greater than 0, so yeah, you can play this game and there are higher chances that you can actually win. You can actually win. Right. This is my first roulette. If somehow you're getting expectation greater than 0, yeah, definitely there's more high chance that you can win this roulette. Now let's create our second roulette. This is my second roulette. It will contain 1, 2, 6 blocks. 1, 2, 3, 4, 5, 6. This will give me what can I do? This will give me win plus 1, plus 1, win plus 1, and this will win plus 2. But this will give me lose -3, and this will give me lose. Now let's calculate roulette for these particular, let's calculate probability or expectation for this roulette. So first we will see the probability of winning, right? How many times you are winning, like 1, 2, 3, 4. So 4 upon 6, and probability of lose, that's 2 upon 6, right? Now let's calculate our discrete random variable x. X will contain three values, that is 1, 2, and 3, right? So x 1, 2, 3, probability of x equal to xi. This x is my random variable. Now let's see how many times you got 1. So 3 by 12. How many times you got 2? So that's just one time. Sorry, not 3 by 12. Instead, it will be 3 by 6. 3 by 6, 1 by 6, and it will be 2 by 6, right? So now let's calculate the expectation. So expectation you can also write as expectation x. Since we are losing 1, so I will do like expectation is always for n trials. Sorry, trials. So I will multiply n, probability 3 upon 6, and value -1. Now I will do for 2, 1, 1 by 6 multiply 2, and 2 by 6 multiply 3, right? Now let's calculate its value. So minus n by 2, n by 3, and n. Uh, 2, right? Yeah. So, okay, wait. Sorry, we are gaining 1. We are losing -3. I'm so sorry for this. Minus n, right? See, yeah, you can see we are losing -1 and gaining +1 and +2, right? Yeah, so 2.6 and -3. So let's calculate this value. 5n by 6 minus n, that will be minus n by 6. So you are getting your expectation as minus n by 6. That means it less than 0. So, so there are 99% chances that you would lose the roulette, right? Yeah. So, so whenever you play the roulette, you need to calculate expectations, right? If suppose you're not win, right? That's what engineers do. Yeah. So using this whole probability expectation, you can always predict that you're gonna win or lose. So that's how these big casino industries already have this data, and based on that data, they bet and actually they win. Like casinos always profitable. Why they profitable? Because they contain all this data, like for which values, for which set the probability, like like they calculate expectation, like for which set the expectation is high, whether it's positive, negative. If positive, that if that is positive, that then it's more chances that you can win. But if that is negative, that casino is always wins. So they always put the name casino always wins. House always wins. So this is the logic behind our roulette, how roulette is being played, right? So I hope you got my point. So we only use expectation to calculate every stuff that we did here. Yeah. So thank you.